this is going to bore some people that have done this before, but you haven't done it. It's a step-by-step approach. And I'll let you do the reading and I'll talk some through the thing. Okay, first off, what we're going to do basically, this is an old, actually, this one's still labeled lifelike underneath where it was built. Walthers bought lifelike, so they inherited their Proto 1000 and 2000 lines. And this is the box, as you can see, is a Walthers box. But it was basically a Reebox straight out of the old days lifelike Proto 1000 line, which is fairly decent detail, but there's no add-ons per se. Driveline wise, it's literally the same as the Proto 2000s, but it's set up with just a single headlight, and that was it. Forward, reverse. It did come with a board, which I'll show you in a moment. Let's go ahead and split through here. Santa Fe had only one set of Fairbanks Morse passenger engines. They were number 90, or the 90 class, and they were Erie Builts. And they're called Erie Builts basically because Fairbanks Morse didn't have any room to build these in their factory. So they farmed it out to GE because GE Electronics is who they were using. Or in that case, electrics. There wasn't much electronic about it. Okay, and they were numbered 90L, A, and C, because at the time, Santa Fe's numbering system was based off of their bukus of FTs, EMD FTs that they had, and they were 4-unit sets, and they were numbered L, A, B, C. L being the lead unit, C being also a cab unit, and then the A and B were the two boosters. So they kept the sets together, they didn't number them individually. So that's the one set for them. All right, here's the package. You can see up close, and there it is out of the box, just for reference. And there's the actual unit right there that I worked on for this. Project goal on this one here, since it had no decoder or anything like that, it was strictly a DC running engine. Add a DCC sound decoder to it, add a speaker with an enclosure so I can get the sound, convert to LED headlight if needed. Turns out in this case it actually had an LED in it. Add 4 ground truck lights. And I spoke to several Santa Fe engineers, 2 of which said they actually worked on these things. And they said that these units had actually 4 ground lights. So both trucks were lit. And they said it was for inspecting the trucks at night. So, and they never said whether you could turn them off front and rear separately. So, said they were all on at the same time. Then add a rear backup light for Santa Fe specs. Santa Fe uses a red backup light on their passenger unit, on their hood units. Okay, so that if the hostler is moving them around separate from the group, anybody in the yard or in the area knows when they see the red light, there's a vehicle, a locomotive coming towards them. Okay, and then I was going to add number board lights and then service the engine as required. Okay, first things are what's needed for this installation. I chose the Tsunami 2 decoder, mainly because it had extra lighting functions and I wanted to use as many as I could. And I chose the one that's the TSU PMP8 type one, and this part number has Baldwin and other diesels on it, Fairbanks Morse being one of those other diesels. And at the time I looked around for Wow Sound and others, they were the only one that had the Fairbanks Morse engine in it, or prime mover. Speakers. 2 sets I was going to do. I had a quad set, and I lost the picture. I don't know what happened to it. But I had a quad set of sugar cubes that I was going to fit into this engine. So one of the sugar cubes I accidentally destroyed. Seems the terminals on them are very, very touchy, and pulled one of the terminals out, which killed the whole quad. I had these, which I was also going to buy. These from Scale Sound Systems use a sugar cube speaker in an enclosure designed specifically for this chassis. And Scale Sound Systems has tons specific to a thing requiring no machine work, which was really nice. Here's the two that go in the other A unit and the B unit. I'll pass around so y'all can take a look at them. And also, at this point, you pass around that double set that are the fitted ones.
Part of the
They make
scale sound
actual
systems,
sugar cube speakers. Prints these as needed. Anybody that wants one, I've got various, all the chassis they support, which is pretty cool. Andy? Okay, those cost, I remember cost-wise on those, they're quite reasonable. They were a little more than the sugar cube. You guys want one in the back there? But they have a sugar cube and enclosure, and it all comes.
How much do those cost?
Pre-assembled. The sugar cube ones that come with enclosures, you see, you'll have to glue them to the thing.
12 bucks
And these were donated, by the way, by Streamline Back Shop. That's a nice thing.
Any projects?
That happens to be a metal.
Okay.
And we'll save some for the next one.
You know what the impedance is on these?
I figured you should get credit. Yes. Okay. Items needed for the installation here are for LEDs, and these are going to be for trucks, number boards, headlights, backup lights, and the ones I'm using for those are the 0402 with leads. You can see here, they're tiny. They're all at the end here. And they usually supply them with a 1K resistor, comes with them, so, and you can buy them bulk on Amazon, Alibaba, a lot of other places. Backup light housings are Details West, and it's number BL162. It's a pile type backup light. They just came in, this is Friday, Tuesday. So I haven't had a chance. They're pewter castings, so I've got to clean them up. I've got to drill a hole through them, through the mounting peg, and drill a hole in the back here because it goes on the left rear of the chassis. So I'll have to get that done at a later date. I couldn't do it for this because it took forever to get them. And 30 gauge hookup wire, by the way, too, which you can get. You can buy a 30-foot bunch of all the colors from Soundtrack, which is nice and handy. These are some of the tools that I used.
Question though.
Yes.
Your 30 gauge wire, is it coated wire or is it actually got insulation?
It's got insulation. It's color coded for
Okay.
DCC.
Okay.
It uses the DCC color codes that the NMRA puts out. Okay, for this case here, since I wanted to be able to remove the chassis and separate the chassis and the shell, I used a JST 1.25 plug, a 2-pin plug on that for the light that's going to be on the rear, which like I say, I couldn't install yet. Small hand tools that are used, you can see their list of them is shown there. Soldering station. These here are kind of unique in that those are aircraft grade from Douglas Aircraft from the 1940s. Mm-hmm. I got them from my mother who retired from Douglas Aircraft Company, and she did wiring for all the cockpits from C-130s to C-124s to DC-8s.
Those are the military models.
Yes, and I've got two sets. One goes from 14 gauge to 26 gauge. Another one goes in 4 steps, and I've got one that goes in 6 steps, smaller. And the 26 gauge will strip 30 gauge wire beautifully. And they don't mess up anything. They're that old and still work perfectly. Okay, these are a pack of the JST connectors, and that's the pack of LaBelle lube, all plastic compatible stuff that you can use on all the locomotives probably in your whole set. If you want to take a look at that, I'll pass it around. Everything okay? Yeah. All right. Okay, also, next on this here, before starting installation, I wanted to evaluate the loco. So basically, I put it on my test track, put it under the non-programming mode, under the driving mode, ran it back and forth, measured the draw in normal running, which was less than 2/10 of an amp. And then I put a stall current on this one, ran up at 840 mils. So less than 1 amp, a 2 amp TSU worked fine for the Tsunami. Okay, then I noted any deficiencies. In the case of this one, at very low speeds under DC, it was a little jerky. And seeing as how old it is, and I bought it still in the box, and I looked at the wheels, it looked like it never been on the track. So grease was getting probably just a little bit thin. So I cleaned all the gearing out of it and everything like that to get it to be ready to lube. Okay, then determined what resistor sizes, and to do that, this is a old power supply that I built some 40 years ago. But I could dial up 14 volts, put it on the track, and use a couple of Fluke digital multimeters, bench tile, laboratory type ones, to measure voltage and current on it. And then I use a decade box, it's right here, a resistor decade box. That's how Pat's ran, if anybody needs to look at those. That one's rated at just over 1/4 watt, 3/10 of a watt, but it works great for determining what resistor size you want on your LEDs. And I can even have an app, you can get an app on your phone that your camera will literally measure the candle power. So you can set them all at the same level if you want by dialing in what resistors you needed. I found that the resistor that was in the nose on this thing for the headlight responded very little to changes in it. The board that came in it has an 8-pin connector on it for the old first DCC ready connections. And on it, basically, they had the front and rear pickup wires to 2 tabs. They had the motor to 2 tabs and headlight to 2 tabs, that's it. But on the board, I noticed there's a 500 ohm resistor and a little cap along with the diodes. And that allowed me to play with it. I started at 500 ohms and it was drawing like 40 some mils. I dropped it to, I ran it up to 1K and it was drawing just over 20 mils, and brightness, I could not tell the difference. So I'm sitting there thinking, hey, I'm going to save all the current I can on it. Sure. Everything draws as little as possible, so 1K resistor is what I ended up going with. And that I found out using the decade box, and you can play with it actually in 1 ohm steps if you are so inclined. Okay, starting with disassembly, basically stripping it to the frame. There's the little board I took off the top of the motor. It was sitting on top of the motor. Does anybody want to see this thing? No, okay. You got to remove the couplers first thing on just about all of these type of bodies. Then you can remove the body shell. In this case, it's very loosely held by 2 little clips that the plastic hooks into. So you just spread it, lift straight up on it, which I have to do again. There we go. And it drops out, and that becomes a chassis. And remove the wire caps from the pins. Light board, keep the screws that came out of it. And you'll notice that it's slightly longer than a decoder. So it mounted in here, if you look, with, okay, that's the top. Okay, we got a screw hole here and here. And that's it, and a pin here and here to locate it. So those 2 screws I saved, and it turns out that the decoder fits perfectly on the front 2 screws. So it worked perfect. So remove the gear covers. It's just a little clip on the top of the thing you pull off. The trucks can then go down, and you can remove those and clean the gears and all things that you can see right here. The gears are exposed, there's the covers right there, and you can clean and lube that and the gears in the drive box. And they ran nice and free at that point in time. I picture slightly out of sequence in that you see I've already mounted the decoder on the motor. Again, I took so many pictures, I could not find the one that had the bare motor. I don't know what happened to it. Okay, preparing the frame, in this case here, for the 4 lights that are going on the ground lights. So basically I noted the positions, if you notice here, where the center of the trucks are, and up on the chassis is where I marked my positions for the holes to drill. Here's the section where I'm actually drilling it using a number 52 drill bit. And if you notice at the bottom here, you notice that the flutes are clogged. I don't know what kind of material the chassis is actually made out of. It's relatively heavy, but it's not typical steel or aluminum. Because when you drill those, you'll get the little curly cues coming out of the flutes. This here, it packed the flutes. So the first drill that I went down, it went down maybe a 1/4 inch and stopped a little bit. I put just a little bit of pressure on it to see what was holding it. Snapped that little sucker right away. So I had to move that hole over slightly and get another number 52 bit.
Hot melt.
Yeah, it must be something like that. So anyway, I go about a 1/4. As soon as I felt the slightest resistance, I pulled it up, and you had to literally stop the drill and pick out with a pick to clean the flutes. But eventually I got through all 4 holes. Okay, in that, then what you do at that point in time is I'm sliding the LEDs in from the bottom. This is actually the bottom, from the top. Slide them down in there, and when you get them just short of flush on there, you put a drop of canopy glue on there. And use that Formula 500, Pictures Formula 500 canopy glue. It's pure white when you put it on, but it dries crystal clear. So I put that on there, and I'd hold it. Then later, I would flip it over, and where the wires came out, I'd also fill that hole in to make sure the wires couldn't do anything. And at that point, I also tested the LEDs. You can check if you've got a digital multimeter handy. Most digital multimeters that are worth their salt at all are current limited. You don't even need a resistor. You can just take the digital multimeter leads and check the LED that way. It won't be very bright, but it'll light. You'll be able to tell that it's still functioning. Because this magnet wire is incredibly thin, and that's what comes on these. Okay, that's done that. At this point is when I also cleaned all the gears and everything and lubed them up using LaBelle 106 with PTFE, which is Teflon. So that grease should last a long, long time. Then the motor. I lubed it with the 107, which is also plastic compatible, but it's meant for armatures. And it works good on that. And at this point, I laid the decoder on top of the motor and soldered it in because it was easier to do it outside of the frame than in. This little black thing here, there's a rubber piece on each side and 2 nubs down here slide into the holes on the bottom, and that's what holds it in. It's not bolted at all, it's simply pressure. The little thing that looks like an F on here actually denotes the front of the decoder. The terminals out here are track wire, headlight, track wire, backup light. And as you can see here also, all the function lights, or function pads. Okay, so installed the motor back in the frame, and at this point it was loose. Screwed it in. Notice one screw here, here's the other screw. I just sunk it in there in case I ever needed it, it was there. And the pin holds the decoder perfectly. Here's the motor connections. The white and blue wire are for the headlight, and the other 2 wires, the red and black, are your power pickups. So I soldered them on, and over here, if you notice, I put my first 1K resistor for the headlight onto the negative tab, because while we think of electronics, normally we think of black, negative as our common. In DCC, positive is the common. So everything is positive, and they run it through, and the decoder simply grounds anything that you want turned on. So the decoder commons are all positives, and that's why this is on the negative lead to the negative lead to the LED. Okay, again, we're basically, you can read through the process here, but I'm connecting all the wires to it. The white wire is now connected to the terminal for the common, and so are, if you see here, the leads. What I did was also took these leads out and routed them, because this wire is real floppy around, and put little CA spots to hold it, keep it from flopping all over. Then I could trim it and run the positives up to the positive terminal, and these are the negatives that go back to the function pad. The function pad, I was going to use one function to turn all the lights on, so I used FX3, which was the very first one. So I put 2 resistors on that, one resistor for the front lights and one for the back, and added that on. And this here twisted wire is my speaker wire, which goes to the S1 and S2, which are your speakers. With a single speaker, you don't have to worry about phasing, so it doesn't matter whether you do plus or minus correctly.
What size wire did you use for your speaker?
30.
Oh, okay, same size.
Same, yeah. The current draw going through it, that was more than enough to carry it. Then I soldered them on, and I used heat shrink tubing to protect the resistors and the stripped part of the magnet wire. And the magnet wire, by the way, is coated with a lacquer type stuff. You don't have to strip it in the traditional sense. Basically put a blob of solder on your soldering iron and just run it through the end of it, and it'll literally melt away the insulation, the laccerish insulation on there, so that you have a solderable tip, and it'll tin it while you're doing it. And all wires, of course, were tinned before I put them on the pads. Okay, beginning the reassembly thing here is, since I wanted the tab, I wanted the shell to be totally removable, I installed the resistor and the wire for the plug on the back where I could separate it in the future. Also, the speaker was dropped in and held in with Kapton tape, and I wired the speaker. Those twisted wires come up here and go to the speaker. If you're using just a single speaker, like I say, the phasing doesn't matter. You don't have to match the positive of the speaker to the positive terminal on the speaker, on the driver, or vice versa. If you're using 2, it's important, because they will run opposite and literally cancel each other out for the most part. So they have to be in proper phase if you use multiple speakers, which is what I could show with that little quad group.
Mm-hmm.
And that maintained my 8 ohms too, because I did 2 parallel, 2 series.
2 series.
Okay, and so the speaker leads are done. That leads me just to the reassembly. And the final assembly here, you'll be able to see all the wire connections and the little holes where the thing comes out, if you want to take a look at that while it goes around. And now it's ready literally for the programming track. Now, unfinished work. Number boards were not open inside the chassis. They're solid. So I'm going to have to come up with a way of, it looks like they are, but when you take and put the light behind it, there's no light pass through. So I'm going to have to come up with number boards where the number 90, the white 90, is opaque but translucent, so I can put lighting behind it. So that's a project for another day. The second thing is, on the Details West backup lights. They come 2 to a pack, and a pack's $1. But I could not find any dealer anywhere that either had them in stock in the quantity I needed, because I have 20 units, AV units of PAs, EMDF units, and this pair of, and these 3, actually I have 2, an ABBA set, but I have a spare B unit because that's the only way you could buy these. So I needed that many packs. I needed 30 packs of these things. And no one had in any quantity. All they had was 1 or 2, and for $14 shipping, which you could drop this in an envelope and ship. So I went to Details West site as a last resort, and there they had the same dollar price, and they had a $30 minimum and $7 shipping. So I said, okay, 2 times 30, that's 60 of them. that should cover me. So I just bought their minimum. And I finally got them in, like I said, Tuesday. Possible super detailing, because there are 3 terrible differences that Santa Fe people are going to notice in a heartbeat. One is that every Santa Fe passenger diesel has 2 headlights, one of which is either a pile rotating or a Mars light. And as you can see it right here, there it is, the second one below that. This one does not have one. So that's a project. And I'll have to come up with the matching red and yellow paint that's on there. Second thing is 2 horns. 1 horn. And the third is 90 had horizontal grills. You notice here over the radiator intakes, they're horizontal far type grills. This has 3 distinct vertical grills. And they're in there because you can see the bars, but Santa Fe covered it. So that's a major spotting point that needs to be fixed. So that, I'm looking for, all I can find so far are the F unit far grills. And I may have to buy one and see if it'll fit, you can cut it to match that side and stack them. But that's in the future. Right now I want to get them running so I can play with them. Did I say that? Okay. Now for programming, I created an entry in Decoder Pro, and that's what I named it. And I did use ATSF because I have UP and other engines and SP, because in Anaheim, which is where my base is, all 3 railroads were there and they interchanged. Okay, program the road number, which is number 90. Program the prime mover, which on this board is CV123 value 6. And program the horns. I've got it narrowed between 2 horns. Talking to those Santa Fe guys again. 4 of them gave me 1 horn, 2 of them gave me the other horn. Now I don't know if this is periodic or time-wise differences, or if the guys just don't remember exactly the same. But I'd probably go with the majority if I can't determine this for a fact and choose that horn out of the choices that are in there. But anyway, CV120 is where that is. Then program the bell. Bells to me are totally subjective, so I'll just pick whichever one I like the sound of better. And you can program the volume levels for every part of the thing, and trust me, in this stuff there's a ton. The DDE, which is the dynamic digital exhaust that is in the Tsunami 2s, lets you make the sounds be incredible, and there's tons of other functions that you can play with on those volumes and on the selections of what you do with the spitters for the compressor and all that stuff. Okay, speed match should be done when I get the other 2 units done. And I have the little tunnel speedometer thing that you can run back and forth to set them up at all the different speeds in the table. And they'll be permanently advanced consisted because they'll always be a group in my planning. Although they will be separated occasionally just so I can use the red backup light. Okay, the sample sugar cubes, like I say, are courtesy of Streamline Backshops. And that's Brian Bianco. Get it? Yeah. And he wanted to donate those. He couldn't be here today because he had to go to Tuscaloosa. And he is a member of our group, and he's attended at least 1 or 2 of our meetings. But anyway, he just wanted this to go out and everybody to get a shot and have some samples. And I'll bring those again for anybody that wasn't here this meeting. And basically, any questions on that?